So today's guest is Professor Yale Pat, who is the Professor of Electrical and Computer Engineering and the Ernest Cockrell Jr. Centennial Chair in Engineering at the University of Texas at Austin. Professor Pat is truly a giant in the field of computer architecture, having won the highest honors in both research and teaching. He's also co-author of our textbook, which is Introduction to Computing Systems, From Bits and Gates to C and Beyond. And Yale, we're very grateful that you could come by today.
It's a pleasure to be here.
So I'd like to talk a little bit about the book. So I think it's really a fabulous introduction to computing. You know, many students here at Cornell and many more taking this course have learned about computing through this book. So you're a very busy person. You've got a lot of things. You've got a big group of graduate students, and you found the time, and you were very motivated to write this book. So what kind of motivated you to write this particular textbook?
The fact is that most students are being introduced to computing incorrectly. In fact, most of the kids you get here in the freshman year have taken computer science in high school, where they've been taught Java, which is a language where the language is such that you can be totally unaware of what's going on and still get the program to work, because the system will protect you from yourself. Mm-hmm. And so you don't really understand what you're doing, but you can get it to work. And I've always felt that starting with something at a high level where you have no idea what's going on is a big mistake. And in fact, the mistake is that what the kids do is they end up memorizing everything. And they hope that they've memorized a pattern that they can then plug in. And they just keep memorizing as they work from the top all the way down to the bottom. I said, it'd be a lot better if they started at the bottom. And there's just a very few simple concepts. In fact, you know the book, so you know that we start with a light switch. In fact, a light switch is very similar to a transistor in its behavior. And kids have been doing light switches since they were 2 years old. So if you tell the kid, you know, you do this, the light goes on, you do this, the light goes off, you know, that doesn't throw them. I mean, they've been doing it since they were 2 years old. So that's where we start. And we use that and we build. So from transistors, we build gates. And from gates, we build muxes and decoders and memory, as you know. And then from there, we build a computer. And from there, we program the computer in its own language. In fact, the first program is written in zeros and ones. And then once they master that, then we write the program in assembly language. And then once they master that, we write the program in a high-level language. So we're constantly building on what they know, raising the level of abstraction. Raising the level of abstraction is good, providing you understand what's going on underneath. And so I felt that this was the way to build the foundation that they need. And education is all about building a strong foundation.
Now, I understand that the book has been used at over 100 universities around the world. So what are some of the places that it's been used?
So the Chinese have bought into it big time. So it turns out that's a good question, actually. And in fact, I should get the list to see how many are in the U.S. and how many are in, you know, other parts of the world. It's used at different kinds of universities. So, for example, it's used at elite universities like Cornell. It's also used at some of these, you know, fifth-rate universities. It's used at places where they feel the right answer is to build on what you know rather than memorize. In fact, I don't know whether you've ever seen my 10 Commandments of Good Teaching, but one of them is
I have seen those.
Emphasize learning, not memorizing, you know, because, you know, we're engineers. We solve problems. We don't memorize. Nobody wants you to memorize and then solve the problem you solved yesterday. You want to solve the new problem, and the way you do that is by memorizing. China is probably the best example. So the book has been translated into Spanish and Chinese.